Hello everybody, my name is Duccio Pappadopulo and I will tell you about my work with Lisa Bauer, Marco Farina, Ozan İrsoy and Mohit Bansal, disentangling online chats with DAG-structured LSTM. Conversation disentanglement is the task of partitioning a multi-party conversation transcript into a disjoint set of utterances, which ideally represent independent subconversations. Disentanglement is relevant to simplify downstream tasks as summarization, question answering, and more generally information extraction. So I'm showing here a snippet from the IRC disentanglement dataset by Kammerfeld and collaborators released in 2019. So you see that there are multiple users whose utterances are interspersed between one another. Now, the coloring on this slide shows a possible solution to the disentanglement problem, where 4 threads have been identified. So, something to keep in mind that is typically a great help when solving disentanglement is the existence of an underlying graph structure in the conversation, which is generated by the existence of an intuitive reply-to relationship. So, when a user is not starting a brand new conversation, they are typically replying or following up on some other utterance. In the following and in the paper, we conduct our experiments on this IRC disentanglement dataset, again released by Kammerfeld and collaborators in 2019. It is a very large dataset containing more than 77,000 utterances with an annotated reply-to structure. In the paper, Kammerfeld et al. Also defines 2 kinds of evaluation metrics that we will also use. Graph scores associated to the binary classification task of recovering the reply-to relations, and cluster scores, which is a much more challenging metric, which is calculated by counting the number of perfectly matching threads. So these slides show the existing results, which are present in the literature, on this same dataset, and as you see, they are not really numerous. So the baseline from the original paper already does quite well just by using a simple feed-forward neural network with encrafted features and word embedding as text representation. So a general conclusion of these results is actually that text seems to be of a somewhat sub-bleeding importance for the task itself. I will now present our methodology. So, starting from the very end, similar to other models in the literature, given a query post, we will construct a representation for it, and for all the previous n posts, which we will call link post, in our case we pick n equal 50, and then we will score the query post representation against each of its links using a feed-forward neural network. We then use these scores to define a probability distribution and assign a single link post to every query post as the argmax of such probability distribution. A query post is allowed to link to itself to define a conversation starter. Now, how do we build the representation? So, query representations are built hierarchically by first encoding every post using a bidirectional LSTM and then feeding each of these representations through a DAG-LSTM. So, what is a DAG-LSTM? Well, it is basically an NRE3 LSTM, which is modified in order to use it on trees, on DAGs, which are not trees. In the context of disentanglement, DAG-LSTM allow us to efficiently integrate metadata like user turn and mentions when building utterance representation. In our case, the children of a given node in the tree, in the DAG, in this case the children of a post, will be defined by its previous post, the previous post by the same user, and the previous post by any user mentioned in the post itself. So link representation, on the other hand, can coincide with query ones. In our case, we decide to augment them by means of thread encoding. So what is thread encoding? So we unroll a GRU unit over the thread which has been assigned to a given link post and concatenate such GRU representation with the one obtained from the DAG-LSTM. So thread encoding is expected to capture thread-specific features such as topic and persona. So some additional details about our method. we introduce a new set of features for fuzzy username matching to detect additional user mentions which are missed by the strict string matching proposed by Kammerfeld. So to improve precision in conversation starter detection, we introduce a custom tunable probability threshold which needs to be exceeded for a post to be classified as a thread starter. Finally, given the high variance that we observe in cluster F scores, hyperparameter tuning is performed by maximizing graph F score and not cluster F score, which is instead more typical in the literature. So in this slide, we then show our result in comparison to those existing in the literature that were already presented before. So as you see, we improve with respect to the existing literature in terms of graph F score. Our experiments show that compared again with a bidirectional LSTM baseline, the use of a DAG-LSTM, our fuzzy username features, and self-link thresholding all provide a significant improvement in the graph score according at least to a McNemar test. Focusing on cluster score, our results are competitive to those in the literature, but not better. This can have various reasons. One of them that we don't hypertune on cluster F. But in general, we want to point out that the difference in the scores mainly stem from a difference in recall that can be attributed to less than 10 true positive clusters on the test set. So to conclude, DAG-LSTMs are a useful tool to model the nonlinear structure of online conversation by enabling us to take user turn and measure relationship into account when building text representation. They show significant improvement over published result in the context of reply to relation detection. Finally, it is worth recognizing that our results add to those that previously existed in the literature in confirming Kammerfeld et al. To be a particularly challenging dataset for disentanglement, where model performance is driven mainly by non-textual features. Thank you for your attention.